All right. So just like the kinetic energy, the GPE also has some helpful information for you, has the equation, it tells you the constant for gravity, even if the problem doesn't say it. Our units are going to be joules for GPE, kilograms for mass, meter per second squared for gravity, and then, because, right, gravity is an acceleration, and then meters for height. Those are set, those are non-negotiable, those are not going to change, they will always be those units. Here's our equation. Our triangle can get rearranged, right? We are not always going to set it up exactly like this. So depending on the variable, we can just rearrange it. You guys are really good at that. And everything I just said is here in the directions. So just like always, we are going to circle what we know, or excuse me, circle what we're solving for and underline what we already know. Notice that there are 4 variables that you see here. Right, we have 4 variables now. We're going to be given 2 of them. One will be a constant of 10, and then we'll solve for the 4th. So, a 3-kilogram blue jay squawking in an oak tree in Mrs. Field's backyard. If the bird is on a branch located 20 meters from the ground, how much potential energy does it have? So, what are we solving for here, Andy? Good. So let's circle that, and that becomes my question mark. So, Caden, give me something that's given. Okay, what's that going to be? What's the M tell you? Is that going to be the height, the mass, or the gravity? Good. And be careful, because that M doesn't stand for mass, right? That stands for 20 meters. So just be careful. Kenna? All right, what's that going to be, mass or gravity? Good. 3, and then our gravity, don't forget, is a constant, which is 10. All right, so I just set this up for the general equation, which is M times G times H. You can also do the dots, doesn't matter, whatever you're comfortable with. And when I plug in my mass, I get 3, my gravity is 10, and my height is 20. You're welcome to put the 3.0 or the 2.0. If I needed the answer to the 10th, then you would definitely need to include it, but you know, unless I'm specifically telling you that, you can leave it off. That's kind of your call, but it's just these calculation things. In a lab, I would be specific and tell you. All right, so what do we get? What do you have, Layla? 600 joules. Good, 600 joules. I like it. So the math on these is going to be pretty simple. There's really nothing shocking. Bless you. Okay. Let's take a look at part B. It says if a 6-kilogram blue jay were sitting on the same branch as the first blue jay, what would his GPE be? Right, so the first blue jay was 3 kilograms. This one is 6 kilograms. Without even having to do any math, what do you think? Any guesses? What do you think, Nevaeh? 2 times, right? Because the mass is 2 times. There's a direct relationship between the mass, the gravity, and the height. So if mass doubles, the GPE is going to double. We could check this real quick. So if I plug in 6 times 10 times 20, I do get 1200, which is twice as much as 600. Right? So you can do it mathematically, but you don't have to either. And you can just kind of think logically. If one of the variables doubles, then the GPE is going to double. There's that direct relationship. Okay. All right. A squirrel on a nearby tree drops an acorn and just misses Mrs. Sargent's dog, Caesar. If the acorn has 255.5 joules of potential energy and a mass of 1 kilogram, how high up is the branch from which the acorn fell? So, Ethan, what do I circle? What do I know? Or I'm sorry, I keep saying that today. What am I solving for? Okay, so I'm gonna circle that, and that becomes my question mark. What is given, Kenna?
255.5 joules.
And
No, GPE.
good, that's my GPE. Good. Brady, what else is given?
10 meters per second.
Good, the gravity. And then what else? What do you think, Billy? Good, and that'll be the mass. All right, so now I'm solving for height. So I'm going to, my equation is GPE over M times G times H. So I'm solving for height, right? So what equation am I going to use? What do you think?
GPE divided by mass times gravity.
Very good. So it's going to look like this, GPE divided by M times G. It looks a little weird, but still pretty easy math. Here's the most common thing that people do, and I guarantee a few of you will do this. You will actually forget to divide it by, or multiply it by 10. You have to do that first before you do your division. So we take our H, our GPE is 255.5, our mass was 1, yes, and our gravity is 10. So you have to simplify the 10 first, right? We need to, in this case it's pretty easy, it's just gonna be 10, but you actually have to multiply by 10 before you do your division. So what is 255.5 divided by 10? What you got?
25.55.
Right, and what are the units gonna be? We're solving for height. What are they always gonna be, Layla? Good. Pretty basic, right? You guys are awesome at rearranging the equation and identifying and plugging things in. So really, again, the only thing that goes wrong is people forget to actually multiply by the gravity. A gymnast exercises by jumping on a trampoline. At her highest point, she is 4.3 meters off the ground and has a potential energy of 11,466 joules. What is the mass of the gymnast? So what am I solving for and need to circle here? Egypt for number 3. What are we solving for though? Yep. What's it want us to find?
Mass.
Perfect. So let's circle that. That becomes my question mark, my great unknown. So Howard, what is something that is given to us that we underline?
The height's 4.3.
Good. 4.3 is my height. Echo, what else is given in this problem? Good. So we have the 11,466 joules. What else is given? Brookston?
The 10.
Good. As soon as you read the problem and realize that it's talking about here on Earth, you can fill in that 10. All right, so you could put 10 there, you don't have to wait. Just like with the units, well, I know the units for mass are gonna be the kilogram. So it's not a bad thing just to fill those units in before you even have the actual number answer. All right, so mass equals, and again, I'm going to rearrange my equation. M times G times H. I'm solving for mass, and so what equation am I going to use here? Brooklyn, what's going to be the equation? Yes. What are we going to have to put over that? There we go. Yeah, so don't forget to include all of that. So GPE over G times H. Now we just plug in. So mass equals, our GPE is 11,466. Yes. 4.3, the order doesn't matter. So we actually have to do that multiplication first, right? So the 4.3 becomes 43, right? And now we're ready to do our final step of division. Always make sure you put the top number in your calculator first, and then the smaller number. And what do we get?
266.65.
266.65,
Yeah.
okay? If you wanna round that, I'm fine with that to 267. Yes. Did I mess up?
Pounds or months?
Yeah, this is not a reasonable answer. I was wondering if anybody would notice. So we would need to multiply that by 2 to get pounds, 2.2. So that is a extremely robust gymnast.
Wait, that's
So,
multiplied by 2.
I'm glad that you noticed that. Sometimes our numbers don't match like reality, and so this is one of those and I just haven't changed it because it's kind of funny to see if people actually notice like, wow, that's a large gymnast.
So these are
585 times 86.
Yes. Fairly robust.
that is a large
Gymnast.
gymnast.
Or just human in general.
That's
Whale.
That's max.
All right. Good. Glad that you questioned that. Certainly first thing on a Monday morning. It's impressive. Okay. Let's look at number 4. On Mars, a rock with a mass of 55 kilograms is sitting on a ledge of a cliff that is 27 meters off the ground. The rock has 5,495 joules of GPE. Based on this information, what is the pool of gravity on Mars? What am I solving for in this situation? Brookson?
Gravity.
Yeah, we're actually solving for gravity, which makes sense because we are not on Earth and we don't know what that is. It's not given at that point. What is a piece of information given, Veronica? Good, and so that's my GPE, 5495. I'm gonna go quickly because we're getting close to being out of time. So we have 55 for our mass, and then the height is 27. So we set this equal to gravity, and it's still gonna be our same triangle. So we cover up gravity. What's gonna be my equation that I use? Gravity equals what?
GPE divided by mass.
Good. Divided by mass times height. Okay, so now I just plug in my 5495 over 27 times 55. I do my multiplication first. And what is that answer? What is 27 times 55?
1,485.
1,485, and now we divide, right? 5495 divided by 1485. Good. And that is actual. I didn't make a mistake on that. That is the actual gravitational pull on Mars. Okay? Keep that paper. It is not homework. We are going to finish it up tomorrow, okay? It is not homework.